Let's have a look at implementing dependency injection. We're going to write a bit of code the way you're probably writing it today, and then we're going to refactor it to use dependency injection. I've got a project here that's already in use. If you want to do this exercise yourself, you can find all the source code here on GitHub under github.com/sswconsulting, and then if you go into the sswtv.devsuperpower.di repository, you can find all the code at a number of the different stages through the exercise. Now let's go and have a look at the solution. To start with, I'm just going to have a look through the models folder. We've got a simple string extension for validating email addresses, a customer entity, an order entity, a file system logger that'll log error and information messages with a number of different overloads, and an email sender that just takes a to email address, a subject, and a body. As well as that, we've got a customer and order repository, and so this is usually we'd implement our data access using something like the entity framework. For the sake of these exercises though, we're simulating that just using in-memory lists. So now what we're going to do is add some admin functionality to our MVC application. We want to be able to see a list of all of our customers and then perform some admin tasks like deleting customers. So to do that, I'm going to come up into my controllers folder, and I'm going to add a new controller. I'm going to make it the customer controller. I'm going to, in my index method, I'm going to get a reference to my customer repository because I want a list of all of the customers. And then I'm going to get a list of all of the customers from there. And then once I've got that list, I'm going to just return it to the view. Okay, then I'm going to add a view that iterates over all of those customers. Okay, so let's have a look at our view. So I'm just doing a for each over each customer. Then I'm adding in the ID, first name, last name, and then I'm going to add a link so that when I click on that link, I can delete that customer. Okay, so the text is going to be delete. It's going to refer back to the delete action method, and it's going to pass in the customer ID. So let's add the delete action method. Return an action result. Make it the delete method. I'm going to accept the ID. Okay, now when I'm deleting, I'm just going to get another reference to that customer's database. And I'm going to call customer database.delete. I'm going to pass in the ID. And now I'm going to return a message to the user that says customer deleted, and I'll tell them what one we deleted. So I'll pass in that ID, and then I'm just going to return that to the user. So we often have a view or something, but I'm just going to return that message. Okay, so that's pretty straightforward. Actually, I should have wrapped that in a try. And now, if there's an exception thrown when we're trying to delete it, we'll return actually, let's make an error message. And we'll say, error deleting customer, and we'll also pass in the ID. Great. Okay, so that's a pretty easy delete method implemented. Now we want to do a few more things in that though. We want to add a bit of logging. When a customer is deleted successfully, we should probably notify the admin department or the sales department. And we might want a bit of logic around not being able to delete customers that have orders. So let's go and implement some of those things. So to start with, I'm going to just get a hold of my logger. So I'm going to instantiate an instance of the file system logger. And I'm also going to want something that can send emails. So I'm going to create an instance of my email sender. Now down here, when I create my status message, but now before I return it to the user, I'm going to come in here and I'm going to say notification.send, and now I can send and I can let know the admin at my company know that a custom was deleted, and I will send that message so they know what one was deleted. And as well as that, I also want to log it to my logger. So I'm going to log it as an info message, and I can just pass in my status message. Great. So now I'm sending the email and logging it to my file system. Now when I get an error, I don't need to send the email, but let's say I want to come in here and I want to log an error. I can pass in the exception and the message. Great. Now I might want to add a little bit of logic up here as well to check to see if the customer has any orders. So I'm going to implement an instance of the orders database. So I'm going to create an instance of the order repository, and I'm going to say I'm going to get customer has orders, and I'm going to say I'm going to look for orders data, and I'm going to get the order data for this customer ID, and we're going to say if the count is greater than 0, then the customer has orders. And now if the customer has orders, I'm going to return a message unable to delete customer due to existing orders. Okay, so now I've added a bit more logic into my delete class to make it a bit more to make it a bit more realistic. So we could continue on building code like this, and everything would work fine for quite a while. So what's wrong with code like this? Well, there's two major problems. The first issue comes up during the sprint planning meeting. Bob, the product owner, comes in and he's got a list of important features he wants added. Let's say he wants to send SMS messages as notifications instead of email. And instead of logging to text files, he wants to change to writing to the event log. Let's say our application has 100 pages. Because we've implemented the email sender and the file system logger explicitly on every screen in our app, changing how we send notifications or write to the log is a massive amount of work that'll almost certainly introduce lots of bugs. The other issue is that we're adding more and more code to the system that is all hardwired together. All those wires between different modules is making our app really complex. Soon it'll start to take longer and longer to add new features. It'll get to a point where a change to any feature you touches requires lots of different parts of the application. And this of course makes it much more likely to introduce bugs and requires a whole lot more testing.